Number 12 says, show that RSTV is a parallelogram for when x is 6 and y is equal to 4.5. Look at the information that they gave to you. They only gave you side lengths, so we need to be working with side lengths. If it's a parallelogram, what we know about the sides is that the opposite sides are going to be the same. So what we're going to do is we're going to show that the opposite sides, when we plug in x equals 6 and substitute in y equals 4.5, are going to be the same. Let's start with RV. RV is 8y minus 8. Now what they tell us here is to use the y, that's 4.5. So we want to do 8 times 4.5 minus 8. So throwing that in, 8 times 4.5 minus 8 is going to be 28 units for RV. Let's go ahead and find ST. ST is 6y plus 1. So throwing that, or substituting in that y of 4.5, so we're going to do 6 times 4.5 plus 1, and we're going to get 28 again. What that means, since these sides have the same length, is it means that RV is going to equal ST. If they're equal in measure, then that means that those segments are also congruent. Now let's look at the next set of sides. We have RS is 7x plus 6, so let's substitute in the x. 7 times 6 plus 6, which is going to get you 48. Then we have ST. ST is 6y plus 1. So if we put in that 6 here, we have 6 times 6. I am not looking at the right side. Sorry, y'all. I grabbed the wrong side. There's RS, and directly opposite is VT. Let's try that one. VT is 9x minus 6. So 9 times 6 minus 6. And so we're going to do 9 times 6 minus 6, which is going to give us, again, that 48. And so now here, RS has the same measure as VT, which means that those two segments are congruent. So let's look at what we have here. We have that these opposite sides are congruent. We also have that these opposite sides are congruent. So RSTV is a parallelogram because the opposite sides are congruent. Let's move on. Number 13, it says the same thing. We're looking to show something's a parallelogram. This time it's GHJK, and we've been given new values and new information. Notice that they've given me angles. Well, inside here, what we have is consecutive angles, because these two angles are side by side and these two angles are side by side. And we have a theorem that says if we can show that this one consecutive angle is supplementary to both of its angles, so both of its consecutive angles, then it's a parallelogram. So that's what we're trying to do, is prove that this is supplementary to J and to G. So let's go ahead and we'll start with the measure of angle K, which is 12n plus 11. So we have 12 times 9.5 plus 11. And that's going to give me a total of 125 degrees. Now let's go ahead and find the measure of angle G, which is 2m plus 31. So let's grab our m, which is 12. So 2 times 12 plus 31, and that's going to be 55 degrees. And then we'll do the same with the measure of angle J, which is 7m minus 29, which is 7 times that 12 minus 29. And again, getting 55 degrees. We're not done yet. We've just found angle measures. But what we can show here is that the measure of angle G plus the measure of angle K is 180 degrees, because 55 plus 125 is 180. And the measure of angle J plus the measure of angle K is 180 degrees, because again 55 plus 125 is going to be 180. So GHJK is a parallelogram because the consecutive angles are supplementary.